Okay, we've got a projectile question here where we've got two things that are colliding in this case. So we've got a football kicked from one side and something kicked from the other side, and they collide. So let's start off by resolving these initial velocities. So we've got 25 is its opposite, so sine alpha, 25 cos alpha. This way here, we've got 15 sine 2 alpha, 15 cos 2 alpha. And yeah, now we can think about SUV80. We're going to think about P and Q. For P, I'm going to go horizontally that way, and for Q, that way. Let's do the easy ones. 0 minus G, you can do that almost instantly. Whenever they meet, the T's will be the same. We've already worked out the U's, so 25 cos alpha, 25 sine alpha, 15 cos 2 alpha, 15 sine 2 alpha. I'm going to call this XP, this YP. I'm going to call this XQ and this YQ. Right, now what do I know? I'm told in the question the total distance here is 72. So that means at any given point, XP plus XQ equals 72. And when they meet, I know that YP equals YQ. So now what I'm going to do is use my Suvat equations there, and I'm going to use this one here to get expressions for XP, XQ, YP, and YQ. Okay, so we have XP is the easy one because A is 0, so 25 cos alpha t. YP is going to be 25 sine alpha t, because we've got ut minus a half gt squared. XQ, so XQ is going to be 15 cos 2 alpha t, and YQ is going to be 15 sine 2 alpha t minus a half gt squared. So now we're going to take those equations and we're going to put them into these formulas. So if we take those over to the other page, we can do that. So we're now going to equate things. So we said that we know that XP plus XQ has to equal 72. So we've got 25 cos alpha t plus 15 cos 2 alpha t equals 72. We also know that when they meet, 25 sine alpha t minus a half gt squared equals 15 sine 2 alpha t minus a half gt squared. We've got two equations here, and we're going to try and use them to find what we need, which was the direction of motion at impact and the height. Okay, so the first thing I'm going to do, I'll probably take that second equation we have. This cancels. I can change this using my trig identities to 2 sine alpha cos alpha. So that's going to leave me with 25 sine alpha t, and if I move that over to that side, minus 30 sine alpha cos alpha t equals 0. I can take out sine alpha from the brackets. I can take sine alpha from the brackets, and I can divide the t out as well. And I'll get 25 minus 30 cos alpha equals 0. So I'm going to have sine alpha equals 0, which is just going to give me alpha equals 0, which I don't need. And I'm going to have 25 minus 30 cos alpha equals 0. So cos alpha equals 5 over 6. Okay. And if I needed to, I could do inverse cos of 5 over 6, but I'm not going to just yet. Right. Now I have a look here. I can now substitute in cos alpha, cos 2 alpha, and I can find a value for t when they meet. Because remember, I'm trying to find the height when they meet. If I find a value for t when they meet, I can substitute that into either yp or yq, and I should get the same answer. Okay, so my alpha is cos to the minus 1 of 5 over 6, which is how I'm going to type into my calculator for the 2 alpha bit. I can calculate that if I want, actually. So if you did calculate it, inverse cos of 5/6 gives you 33.5573 and so on. But I've left it exact in my calculator. So then I've got 25 times by 5/6, because that's cos alpha t, plus 15, and then if I multiply my alpha by 2 to cos of my answer, I get 7 over 18 for cos 2 alpha t equals 72. When I rearrange that, I end up with 25 times by 5 over 6 plus 15 times by 7 over 18, which gives me 80 over 3t equals 72. So t equals 72 times 3 divided by 80, and I get t equals 2.7. So 2.7 is where they meet, is the time when they meet. So time when meet. Okay, so what we want to do is find out the height at that point. So the height at C, we can take either of them. So I'm going to take my y for, it doesn't really matter, does it? Let's take yp. So we've got 25 sine alpha t minus a half gt squared, so a half 9.8 t squared. And we substitute in what we know. So we worked out alpha was 33.3, t is 2.7, and when I work that out, I get 1.59 meters. So we've answered the height of C above the ground. Now we want the direction of motion at that point. So in order to think about that, we've got to think about the velocity horizontally and the velocity vertically, and then we can calculate both. So, and we're doing it for particle P. So we're using, right, so we have to use V equals U plus AT. Now remember, V and U horizontally never change. So my V horizontally is just going to be 25 cos alpha. My V vertically, however, is going to be 25 sine alpha minus AT. So my X, I want to find my T when they meet, and yeah, minus GT. Perfect. So G, and we know the T when they meet, which was 2.7. Right, so now we can stick that all into our calculator. So we get, so we're going to do 1 divided by the other for the direction. So if I do this one, inverse, so we have as our inverse cos, sorry, 5/6. Oh wait, cos alpha is 5/6 already, sorry. 5 divided by 6 times 25. So 125 over 6. And then, and we want to sine that, times it by 25, minus 9.8 times 2.7. and that gives me minus 12.64. So my horizontal is 125 over 6. My vertical is actually going down, so 12.64, and I'm looking for that, okay? So the angle I'm looking for is this angle here. So I want my direction of motion. Well, I could have looked for another one and then I have to compare it to the vertical. So I've got my opposite and I've got my adjacent. So tan, let's call that theta, is going to be 12.64 over 125 over 6. So that tells me that theta equals, sorry, this has got a bit long, in shift tan of 12.64 over 125 over 6, which gives me 31.2. So when I'm writing my answer, I'm describing that as below the horizontal. So the direction of motion is going to be 31.2 degrees below the horizontal. And one improvement, air resistance is always being a good one if they don't. Air resistance to be taken into account. Occasionally they say, what is an improvement excluding air resistance? You could say you could take into account the size or the shape of the balls, you know, something like that. Okay, so as a recap, if we've got two things, we're going to think of SUVAT for both of them, think about when they meet, what happens, and then work through the algebra. This bit is just long, try work through it slowly. I know I've rushed through it, it's to try fit this video in. So, hope it makes sense.